Hi guys, this is Marvin and today I wanted to show you how to create this simple Tetris clone. In the first part of the tutorial we only going through the basic concepts. We just have the movement, we also have the clear line mechanics, and that's it. So you will learn how to do this in Unity. Hope you will have a lot of fun and enjoy the tutorial. We're first going to set up a new project in Unity Hub. So we select 2D because we wanted to create a 2D template, and we just name it Tetris, create project. It's creating it and I will come back to you when it's created. Here we go. The first thing I do is I open the project settings. I go into editor and I just set a check mark here, enter play mode. This will prevent reload domain and this will make the whole compiling process way faster. The next thing, we are going to import some assets. The first one, it's this grid over here. We are using it later. And then I have just a package which you can download. I will put it into the description. I already purchased it through the Unity Asset Store and it's called Puzzle Blocks. So I go here, packages, my assets, puzzle block. You need to first purchase it with your Unity account. It's for free. You download it through the package manager and finally you go to import. We now want to go and drag and drop one of those blocks into our scene view. We're just using a blue one over here, putting it in. And now you can see that we have a little problem because here in the scene view, there are these units. What we are aiming for is that one of the blocks is exactly 1 unit. And to do so, we need to change the import settings of the sprite we are importing. You can see that the size of this sprite is 512 times 512. And so we wanted to change the pixel per unit to exactly that amount of pixels. And when we're going to apply, you can see that it's changing, and right now we just have a block which is exactly the size of 1 unit. That's what we're aiming for. Awesome. I will go and reset the position to 0, 0. Now we are going to create the grid for Tetris. We are just drag and drop our grid texture here. You can see that we have the same problem actually. The Unity grid is smaller than the sprite, so we check the dimension over here. It's 192 times 192. We're going to apply this, so our grid tile is exactly the same size as one of the units. And now we can use the draw mode tiled to repeat this pattern. We wanted to have width of 10. That's a normal size for Tetris, and height of 20. And here we go for our grid. The next thing is we wanted to position it properly, and we wanted to make sure that whenever there is I'm just wondering why it's okay, the scale just changed. We wanted to have scale 1, 1 for whatever reason. The scale was different, and now you can see that the block size exactly matches the size of one of the grid cells here. And the next thing we want to do is we wanted to position the grid so that the block at position 0, 0 is exactly at the left bottom corner. This is pretty important. That will make the life way easier for us when we're creating scripts. So let's see if it all matches up. I think we can just enter these values here so it's more accurate. We can use 4.5 and 9.5, and here we go. That looks quite promising. We have exactly the right measurement, I think. So I also changed the camera aspect ratio, so we have a more Tetris style aspect ratio, and I also changed the camera. I changed the camera to perspective and changed the camera position to 5, 10 and -20. So we have a perfect overview of the whole Tetris grid. We're now going to write our first C# script. This is the grid script. Grid script. And this basically takes care about the position of all the blocks we currently have in our grid. I just open it with VS Code. Here we go, empty script. And I will just declare some public variables we need to use later on. The first one is a two-dimensional array of transform components, which is basically the grid we are taking care of, all the blocks we are having inside of this grid. And we also wanted to have a public integer variable, which we set in the inspector for width and height. And we can also go into the start method over here, which will be called when you start the game inside of Unity. And we can just initialize the grid. Grid is equal to new. There's auto-completion. Here we go. That looks quite good. Saving it, going back to Unity. Here we see that those variables got exposed to the inspector, and we can set them from here, which is quite convenient. So we just go for the default values I used previously for setting the grid tiles. We are going to add some game logic now, and we're doing that inside of a new script we just call game manager. Oh, here we go. Open it in Visual Studio Code once again. And first we wanted to create some variables we just need in order to make it working properly. The first one is a list of game objects, and basically it should contain all our possible Tetrominos, which we will define inside of the Unity editor later on, and then assigning the list of those game objects into the in the inspector to that script over here. We also wanted to have a public float variable, movement frequency, so we know how often we should update or move the blocks. So we are going to set it to 0.8, but you can change that as you want. And we also, because we wanted to take care about the movement frequency, we also need to introduce a variable past time, where we just check how much time is actually or was passed during the last update. Because we wanted to spawn Tetrominos inside of the script, we also wanted to have a private variable, private game object variable called current Tetromino, which will take care about the currently spawned Tetromino we are moving downwards or sidewards. For the start, we are just going to call a method which we will create later on. We will say spawn Tetromino. Pretty straightforward. This is the first thing which should happen. We should have something to play with. And the next thing we are going to do is we create an update method. And here we are just taking care about when exactly the game should update. So for this reason, we are just getting the delta time, which is a time passed during the last frame. And if our past time is larger or equal to the movement frequency, we know that it's time to update, and therefore we need to reset our past time, we need to subtract the movement frequency, and we also wanted to call a method we will introduce later on called moveTetromino. And this one we just passing a vector, so the method knows in which direction we wanted to move it. So we are going to say vector3.down. The next thing we are going to do is we wanted to create a new script which is taking care about spawning Tetrominos and moving them. So we are going to introduce a new script called the game manager. And inside of this one, we also wanted to introduce some new variables. So the first one is a list of game objects. We wanted to have our Tetrominos over here. We will assign them through the editor later on. We also wanted to have float variable, which is defining how often we should do movements. We call it movement frequency, and we set it to 0.8 right now, but you can just change this value. And we also wanted to have a value, a float value, which is tracking the past time. More about this in a second. And we also wanted to have a private game object variable, which is taking care about the current Tetromino we wanted to move inside of the grid. So this is it about the variables, and first, we wanted to have something inside of the start method. So this method is executed whenever you start the game inside of the Unity editor or on a device you build it for. And here we just wanted to spawn a new Tetromino. the method I will introduce in a second. The next thing we wanted to do is we also wanted to take care about the update loop, and a basic update loop should definitely add the past time to our past time variable, the time.delta time. It's containing the time which it took to render the last frame. So now we know how much time was passed, and we wanted to say if the past time is larger or equal to our movement frequency, we know that it's time to make a move. And for this reason, we just reset the past time. And we also wanted to call a method move Tetromino, where we just pass vector 3.down because we wanted to move the Tetromino downwards. And finally, we wanted to take care about the user input. So these are the methods we need to write. The first one is spawning the Tetromino. Spawn Tetromino, doesn't take any parameters. And we're just going to first get a random index from this list. And we're doing so by just using random.range parameter, range. Starting from 0 and up to the length of the array we wanted to get an index from. And now we can do something pretty cool. We wanted to assign a random Tetromino to the current Tetromino variable. We can do so by using Unity's instantiate method, which is cloning a game object. And we wanted to get one randomly selected from our game object list. We wanted to set a new position to it. This one I just figured out is pretty good because it's at the top of the grid and it's in the middle, so it's top middle position, quite good spawning point. And the last thing we want to define over here is identity rotation, so it shouldn't have any rotation at all. And this is it for the spawning method. We also wanted to introduce a move method. This one, move Tetromino, takes a vector 3 direction as a parameter, and we wanted to move the current Tetromino, so using the transform component and adding the direction to its position. Now we wanted to check if it's a valid position we currently have our Tetromino moved to. So it could be the case that we move the Tetromino and then it's outside of the grid view, and this wouldn't make it a valid move. And for this reason, we just using a new method, which we will implement later on, is valid position. If it's not a valid position where we moved our current Tetromino to, we wanted to revert the position. So we are going to say, okay, if it's not a valid position, who cares? We are just going backwards. So now it should be a valid position again. And we also wanted to add some more logic here. So we are saying if it was not a valid position and the direction is equal to vector 3.down, because we moved the Tetromino downwards, then we know that we are at the bottom of our grid and the Tetromino shouldn't move any farther downwards because it can't. And we wanted to update our grid script, adding the new Tetromino to it. And we also wanted to spawn a new Tetromino and check for full lines. So this is a lot to do, but basically we will just getting the grid script over here. The grid script, once again, it should take care about all the positions of the Tetrominos and blocks inside of our grid. We wanted to update our grid, and we wanted to pass the current Tetromino's transform component to it. We will later on implement this method. And because it's not too important right now to just see some movement, which I wanted to show first, I will just comment out this one, but we are going to use that later. We also wanted to check for lines. So we wanted to check if there is any full line which the user has completed. And we also wanted to spawn a new Tetromino because we know that we are at the bottom of the grid. The check for lines, we are just going to implement an empty method right now, but we are going to fill it with logic later on to do implement later. We also wanted to introduce a method for the isValidPosition. For sake of simplicity, we are just saying for the moment that it's always a valid position, so we don't have any collision detection or something, but it's just enough to demonstrate that we can move a Tetromino, which will be the first thing we wanted to do. It should return a Boolean. Okay, all right. Now we also wanted to add a method for the user input. So we wanted to handle user input. We are going to say void user input, doesn't take any parameters. And now we are just going through the different inputs we can have. So for this, we are using Unity's input module, saying get key down. We're using keycode.left arrow. We're just checking if the user pressed the left arrow. If this is the case, we wanted to move the Tetromino vector 3.left. Pretty straightforward. We can copy that one, saying, okay, if that's not the case, perhaps the user clicked the right arrow. If so, we wanted to move the Tetromino right for sure. And we also wanted to check for an upwards movement. If that happens, we wanted to rotate the Tetromino, which we do with the same logic as before. We just rotate the Tetromino, which we can do with the rotate method. We wanted to only rotate it on the z-axis, and if this is not a valid position, then we are going to revert the rotation. So this is just for collision detection, and once again we will implement logic for this method later on, but we are going to revert the rotation if it's not valid position. So this one is enough for making a potential Tetromino move, and the next thing we want to do is we want to create the Tetrominos. So there are different ones. I've done a little bit of research, and it just turned out that there are basically how many? 1, 2, 3, 4, 5, and we are going to implement those right now. This is really simple. We are just going to create a new game object. We are doing it with Shift, Command, and N. You can also do it in the menu over here in Unity. We are saying we wanted to have the straight one, setting the position to 0, 0, 0. And then we have our blue cube over here. Oh, it's pretty interesting because you can't see it in the game view. You see that? So we have the grid over here and we have the block. But in the game view, it's not on top of the grid view. And this is because of the order in layer. We definitely wanted to increase the order in layer to 1 for our blocks because we wanted to have it in the foreground. And now we can just go here. We can duplicate the stone. I'm just doing it with Command and D. I'm putting that into the straight one over here. Duplicate it once again. I wanted to have 4 of those. And now we adjust the position. We are going to set it to 1, 2, and 3. And another thing which is pretty important for the rotation thing is that we wanted to set the anchor a little bit different. You now see when I just select the parent game object for this Tetromino that the anchor is over here. And when you rotate the tile, it rotates around this point. And what we wanted to have is we wanted to rotate it around another point. And for this reason, I just move all this Tetrominos a little bit to the left. So our anchor is right now over here, but just seeing if the positions are okay, I will just round them once again so it's more accurate. -1, 0, and 1. I don't want to bother you any further, so I will just create all the other ones and then we see us again. So I now implemented all these different Tetrominos. I added different color to it. The only thing you want to notice is the size of the sprite. So for example, I wanted to change, let's see, the color of this one. I wanted to have it a more, I think we don't have red inside here, so I just wanted to assign the red sprite for the redstone. I'm just marking all those, adding this, and you can see that the sprite is going to be very large, and that is for the same reason as I mentioned before, that the pixels per unit is not equal to the size of the sprite. So we adjust it, saying apply, and now it looks properly sized. All right, we have all those Tetrominos, and we wanted to add them to this list of game objects over here. So we have 1, 2, 3, 4, 5. We're going to make 5 here, and we just drag and drop all our Tetrominos. And we are going to write some more logic for the game script, because what we wanted to do in the end, we wanted to connect the grid script with the actual game manager. Next thing we wanted to do is we wanted to create this update grid method. So I will just add this one, and we wanted to have an update grid method inside of our grid script, which contains information about all the blocks which are existing inside of our grid. And we just pass the transform component of our current Tetromino. So we are just going in the grid script, and we create a new public void method, update grid. We are passing a transform component, which is the transform of our current Tetromino. And now we wanted to create a nested for loop, which is iterating over the y and x component of our grid. As long as y is smaller than the height of our grid, we say that we just wanted to increment it. And same goes for the x component. So int x equal to 0. X must be smaller than the width we defined over here. And we just increment x as well. Now what we wanted to do is we wanted to check if at the current position we have, so at grid x, y, if there is anything. So we check for null, and we look if there is anything inside, if there is a block in this position of our grid. If this is the case, we wanted to check if the current position we are looking at, if the parent of that is our Tetromino. So we basically wanted to check if our Tetromino is at this position, or one of our blocks from the Tetromino is at this position in our grid. And if that is the case, we just wanted to reset that right now. Basically, we wanted to remove all the blocks from our grid, which are from the current Tetromino. That's it. After we have done that, we wanted to reapply the, we wanted to re-add the position of the current Tetromino to our grid variable. And to do so, we can just say we wanted to iterate over each mino, or each block inside of our Tetromino. Because what we have done when we're talking about Tetromino is basically about those game objects over here and about the transform components. And inside of each of those, we have child components, which are basically our current, our blocks, our Tetris blocks. Hope that's clear enough. And we're going to have the position of the block. We wanted to round that just to make 100% sure that it's an exact value, an exact integer value. And for that reason, we are going to introduce a new method called round. I will just implement that in a second. We'll go here saying that we have a public static vector2 round method. We are expecting a vector, and we just round the values to the next integer. So return a new vector and say mathf.round using the x component and the y component as well. And we're just returning that. If we have that, we wanted to check if post.y smaller than the height of our grid. And if that's the case, we can just set the new position inside of our grid, or the new block inside of the grid. So we just rounding, parse.x and rounding to int parse.y, and we just applying our new Tetromino block to this position inside of our grid. So this is it for the update grid method, and now we are going to implement the isValidGrid position as well. So do you remember we had this method over here, isValidGrid, and we now wanted to make sure that it's calling the isValidGrid position from our grid script, because it makes a lot of sense to put it into this grid script, because the grid script knows exactly which block is at which position, and so we can easily check if it's a valid position. So we just wanted to pass, let me check, we just wanted to pass the current Tetromino's transform, that's all good, and we're just going to implement this right now in our grid script. So we say public, it should return a Boolean value if it's a valid position or not, and we're expecting a transform component. It's our current Tetromino, and now we wanted to go over each mino in Tetromino, so we're going over each block. We wanted to get the position, we wanted to round it using our rounding method here. We wanted to pass tetra, or the mino, the block, dot position. And now we wanted to check if it's inside the border, if the position is inside the border. So for this, I will just call another method, is inside border. We're passing the position, and if this is not the case, if the block is not inside of the border, for sure we will return false because it's not a valid position. So this is the first one we wanted to check, and the is inside the border is a pretty simple check. Public bool is inside border. We're expecting a position parameter, vector 2, and we're just going to return if the position dot x, we are rounding it to integer, is larger than 0, and position dot x is smaller than width, and we're doing the same checks for the height. So we wanted to make sure that parse dot y is greater than 0 and parse.y is smaller than height. Now we know that it's inside the border, so this method looks okay right now. And now we wanted to check if it's if the Tetromino is colliding with any other inside of the grid. And to do this, we wanted to introduce a method getTransform at grid position. This method should just return the transform at a current grid position. We are going to implement it right now. Public transform get, I'll just copy that. It's taking a vector 2 position, and what we wanted to do is we wanted to check if parse.y is larger than height, -1. If that's the case, we know that it's outside of our grid, and we return null. We don't have it inside of our grid. Otherwise, we just return the content of our grid. So we are going to round this to integer and just return whatever is inside of our grid. So we are going back to the isValidPosition method, and if getTransform at grid position is not equal to 0, and if getTransform at grid position for the current block we wanted to check. If the parent of that is not the Tetromino we are currently wanted to check the position for, then we know that it's colliding with another Tetromino, and for that reason we just wanted to return false. In any other case, for now, we can just return true. So when this, for each, when we check every mino or every block in the Tetromino, and we are sure that it's inside the border and that at the current grid position there is no other block, or the block is from the Tetromino we are currently checking, then we know that it's a valid position. And that's it for this logic. We are just saving it. We are saving this as well. I don't know why there's a problem. Oh, okay. It complains that it doesn't return a value, so we just need to return this for sure. And we can just see if it's working. Okay. I will just move all these a little bit outside so that it doesn't interfere with our grid. Just let me double check. We have those here. It's pretty important that those are assigned, and we can just hit play. Let's see if we can play a round of Tetris right now. So I press button up. You can see that the rotation is working properly. Depending on where you set the anchor, it's rotating differently. We can't move outside the border. I'm trying to go left and right, but it's not working. When we reach the border, it's spawning a new random tile whenever we're hitting the button. I can also check what happens if we just reach another block inside of the bottom of the grid. So it should stop as well. Looks quite promising. For having a very basic version of Tetris, we definitely also wanted to add the move down faster functionality, and we wanted to trigger that when the user keeps pressing the arrow down button. For this we are using the get key method. You may wonder what's the difference. So over here we are using the get key down, which is only true in the frame the user hits the button. So the get key method always returns true when the key is hold down. So as long as the user holds down the down arrow, we wanted to set the movement frequency to 0.4, and if it's not the case, we can just reset the movement frequency and set it to 0.8 once again, just checking out if it's working as expected. Here we have a problem. Whenever there's an L Tetromino spawning, it doesn't properly recognize that it should go down, and it's spawning a new one. So what we probably wanted to do is we can just change the position at which we spawn the Tetrominos. So we can just say we wanted to set it to 18, and we also wanted to decrease the movement a little bit. So we want to set it to 0.2. So every 0.2 seconds we wanted to have an update when we press key down. That looks way better, moving way faster now. And now also the L Tetromino is spawning correctly. The last thing for this tutorial will the implementation of the check for line method, which should check if we completed a line, and if we complete one, it should delete the line. So we just propagate this logic to the grid script. It makes a lot of sense because our grid has knowledge, our grid script has knowledge about all the blocks inside of our grid, and here we can check the best if we have any full lines. So we just need to implement this method over here, public void check for lines. And inside here, we wanted to go through every Y component or every Y inside our grid. Just starting by 0, we are doing it until we reach the height of our grid, and we are incrementing Y. We wanted to check if line is full for our y component. We are creating this method very soon. And if the line is full, we wanted to delete this line. Delete line. We also wanted to decrease all lines above, starting at y plus 1. And we also wanted to decrease y by 1. We are going to implement those methods right now. The first is line is full. We are expecting one parameter, the y component. And we just wanted to go over each x inside of our grid until we reach the width of our grid. Wanted to just increment x, and if at the current position there is null, so there's nothing, we know for sure that our line is not full and we can safely return false. But if we went through all the items and none is empty, we know that our line is full. And at the end of the for loop, we can just return true because we know our line is full. The next thing is the delete method. It's a void one. Delete line. We are just taking this y parameter over here. We are going again through every x in our grid until we reach the width. And we call a unity method, which is called destroy, because we wanted to destroy the block at this position. We're using the game object. We wanted to destroy the complete game object, not only the transform component. And we also need to assign null to this grid element. This is it for the delete line. And finally, we are also going to implement the decrease raw. It's a void method, just copying it from over here. It expect one parameter, the y component. It's a start raw at which we wanted to start, decreasing all the raws. And here we go over each y component, starting from the start raw, while y is smaller than the height of our grid, and we just increment y every time. And then we wanted to go over every x component, starting from 0. X must be smaller than the width of our grid. We are incrementing x every time. And now we are just checking if at the current position, x and y, if there is anything. So if it's not null at this position, we are going to use the line below, the line we previously deleted, y minus 1. This is an empty line for sure because we deleted it previously. And at this position in the grid, we just wanted to set what we previously had at the x at the current x and y position. So we just wanted to move this block one down. We also wanted to set this to null. And finally, we also wanted to go to the block below, which we just moved. And we wanted to also change the position of this one. So we are going to add vector 3 dot down, so we move it down by 1. And this should be it. So we can just check it out and see if it's working as expected. And just starting over here, now I need to complete a raw, having a full line. Oh, that was pretty fast so far. Let's see what I get the next. Yep, that looks promising. I will just go completely down over here and it should delete the raw. And here we are. That's a pretty simple Tetris clone. And in the next tutorial, we are going to improve this version a little bit. So we have a high score and we have some other elements very well known for Tetris. Anyways, I hope you enjoyed this tutorial so far. You had some fun and hopefully you will create a very good own Tetris.